Yeah, I think the live streaming has started. The live streaming. Okay, fine. The stream is going on. It's fine. We will start the session. So yesterday we are done with installation of Arduino IDE, right? So
Yes, sir.
what's the purpose of Arduino IDE?
Sir, it can used for, like, we can program into so that it can be done into the hardware of Arduino.
Yeah, right, perfect. So in Arduino IDE, we will be doing the program which can be uploaded into any hardware. So not only Arduino board, like there are multiple Arduino boards available. See, if you just check the different kinds of Arduino modules. So recently, the Arduino has collaborated with Qualcomm company. So and they released a new module called as Arduino Q. Okay, Arduino Q. So this is the Arduino Q. If you just check the pricing of the Arduino Q, it is very high than the usual Arduino UNO. The UNO is available at lower prices, something like maybe in less than something like 300. Within 300, you can get a UNO module. But whereas coming to the Arduino UNO Q, so where Q refers to Qualcomm. Okay, both the companies of Arduino and Qualcomm collaborated with each other. Now Arduino is acquired by Qualcomm, so they have added more advanced functionalities. It's like a tiny computer. Yono Q is like a tiny computer. So see, it's basically we are having many integrated circuit IC on it, Qualcomm IC. This is the Yono Q. It's like a tiny computer. Okay, and I will be showing you the Raspberry modules also. They are like the highest form of even more prior having more priority than the Arduino modules. So I will be showing you the Raspberry module with you. Raspberry Pi 5. See, the pricing itself is from that you can understand it's an expensive module. So basically, many of the hobbyists, rather than buying a new module, usually they get a second-hand module at a lower price. So there are various communities like various WhatsApp platforms and huge electronic communities where you can get a second-hand Raspberry modules also. If you get a second-hand Raspberry module, you can start working on it rather than buying a new one. You can literally do some cool, interesting stuff, how it works. You can analyze different things, okay? And you can do some Linux programming or system level Linux programming. Everything you can do in these modules, okay? This is how a Raspberry module would look like. It's like it's like a complete mini CPU itself. So basically, you can connect a keyboard, mouse, any peripheral device. So you can connect any peripheral device like keyboard, mouse, or any other something like a barcode scanner and a fingerprint sensor. So like this, you can connect to many peripheral devices, and all these peripheral devices communicate with the Raspberry module. It's like a connect if you're as if you're connecting some peripheral devices with your PC, personal computer. Similarly, you can connect the different kinds of peripheral devices to this Raspberry module also. And we also said that yesterday a few things about ESP module, right? We discussed a few things related to ESP module. So I said that there is something called ESP8266 or ESP82, and the another variant of ESP is ESP32. And I told that ESP82 is not having the capabilities of a Bluetooth functionality, whereas ESP32 is having the Bluetooth functionality. And moreover, ESP82 runs on a single core, whereas ESP32 runs on dual core. So it can do more tasks. It can run different kinds of tasks simultaneously. It can perform asynchronous and synchronous actions, right? With the help of dual core. So coming to this Arduino, now in this curriculum, we will be learning about Arduino UNO and the beginnings, basics of Arduino programming. So what are the different kinds of libraries that we use for Arduino thing? Okay. And one more thing is like there are multiple Arduino simulation tools available in the internet. So I'll show you a few of them. Arduino simulation online. Just for Arduino simulation online, there are multiple online simulators through which you can simulate. Uh, you know, uh, since you will be ordering the Arduino kit very soon, probably you can place an order today. Our team will send you the link right after the session. So till before the Arduino has arrived to a destination, till then we can work on the simulation also. Just like as if you are doing the programming on an Arduino IDE and then uploading the code into the hardware. Here similarly, here we have a workspace on the left side. Here you can do the program. Okay, and whenever you just run this program, that will you can simulate it over here. You can do connections and everything over here. So this is basically an online simulation tool. Like this, there are multiple simulation tools. You can just explore them. Walkv is one of the tool. Circuit Designer is also one of the famously used tool. I'll show you this one also. Launch a Circuit Designer. Here you can add breadboards, just like as if you are working in a laboratory or else a lab. Here you can add a breadboard. Let's say you want, here we have three different types of breadboards: mini breadboard, full breadboard, half breadboard. Let's say I want some full breadboard. You just click on that, automatically breadboard would appear. So like this, you can do simulations also here. Even though you're not having a physical Arduino module with you, you can do the simulations. But it is always advisable to work on the Arduino module practically, so that you will get uh, useful insights. You can understand much better. This is how you can do simulations over here. If you want to do connections, you can do the connections as well. Like this, you can connect the different uh, GPIO pins. Basically, do you know the full form of GPIO?
No, sir.
Okay. So just I hope you have a notebook with you. So as we discussed, like in the introductory session, you must have a notebook and pen readily with you. We'll be sharing few of the things. You need to note it down because you are very beginner to Arduino, right? So basically, GPIO means general purpose input output. Okay. GPIO, the full form of GPIO is general purpose input and output. So every
Yes,
microcontroller or
sir.
every board, not only just Arduino or ESP or Raspberry. So every microcontroller architecture will have few GPIO pins on it. Okay, there are mostly two different types. So one can carry data signal, I mean digital signal, and another can carry analog signal. Right. So basically, you have two different kinds of thing. Even in electronic systems, you have digital signals and analog signals. So do you have any idea what's the difference between a digital signal and analog signal?
I've heard first time.
Really? It's actually you have a complete subject. Maybe in the upcoming once you are going uh, more deeper, you will get a subject later on. Maybe in the upcoming sessions in your BS curriculum also. There is something called uh, something like digital signals and analog signals. You will get this in signal systems and processing. See, in that concept, you will get two different kinds of signal: digital signal and analog signal. So I'll show you. If there are different waveforms also, I'll show you if possible. Digital signals versus analog signals. Yeah. So here we are having a straightforward definition. I mean, a straightforward explanation for analog signals and digital signal. Analog signals are continuous flowing waves that vary smoothly over time, whereas digital signals are discrete, consisting of distinct numerical values. So basically, you just assume like, for example, if you have a square waveform, okay, a square waveform is like an example for digital signal. I will show you the square waveform, digital signal. See, this is the square waveform, okay. So what does this signal represent? Any idea? So always whenever we are talking about signal, so what actually does signal refer to? Is it something rocketry science? What exactly? How you interpret a signal? How can you understand this square waveform?
I think it will be expressed as a form of graph as a function.
Yeah.
I
So
mean, since we have learned in maths about the functions, it seems like it can be represented in graph.
yeah, okay, it's fine. It's a graphical representation. It can be analyzed mathematically. But here we need to understand that, let's say if you take on the x-axis, if you take the time as the reference, okay, on x-axis you take time. So from this we can understand that something is varying with respect to time, right? So something is varying with respect to time. Time is on x-axis. So on y-axis you need to take the voltage. So whenever any person, any mentor or whoever may be, whenever they are referring to any signal, so you need to interpret that something is varying some with respect to time, that is voltage. So voltage is varying with respect to time. Depending upon the way how it is varying with respect to time, we can derive a mathematical equation. So based on that mathematical equation, we will obtain different kinds of waveforms, like a square waveform or else a sawtooth waveform. There are different kinds of waveforms available. Ripple waves. There are different waveforms. So, but ultimately, the quantity which is varying with respect to time is the voltage. Okay, that is the main thing that which is varying with respect to voltage. So let's say, yeah, so this is the digital signal. So if it is high, okay, this is the high position. So I'm sure that you might have, maybe even in your BS lectures, I'm sure that you might have heard the term something like high low, isn't it? Have you heard the term high low?
Yes, sir.
So what do you mean by high and what do you mean by low? High and low, you might have heard
Sir,
many
I
times. Yeah.
sir, actually means that how high it is from the x-axis and the low is something uh, at the mid of the y-axis.
No, no, that's not exactly how you need to interpret it. So high refers to a higher voltage, okay, and low refers to in the complete electronic system subject. High refers to higher voltage and low refers to low voltage. So what's that low voltage? It is usually taken 0 volt as the reference. If the input voltage is 0 volt, then it is called as it is in low state. So if the input voltage is high, then it is called as high state. Okay. So then what should be the voltage if to make the system to be in high position, okay, or higher state? So there are different voltage references, okay, not just a single voltage, there are multiple voltage references. Let's take the example of ESP32. So ESP32, it operates at 3.3 volt. So the entire system of ESP32 architecture is built to operate at 3.3 volt. See, what's the voltage that we get in our houses from the power, I mean, transmission lines?
It's 220 volts.
Yeah, something like 220, 230, 240, yeah, 220 volts. That's fine. So, but all these electronic modules operate at lower voltages. Am I correct or not? All the electronic modules, probably the different kinds of sensors, these usually operate at lower voltages. So in the big earlier session also, I might have told you that usually many sensors operate in between the voltage range 3.3 volt to 5 volt. Okay, many of the modules. So few modules even operate at 1.8 volt. Okay, 1.8, 3.3, 5 volt. These are the standard voltage references. So ESP32 operates at 3.3 volt and Arduino UNO operates at 5 volt. Okay, this is the very first point that you need to understand. Different boards operate at different voltage ranges. Okay, operational voltage range. So ESP32, ESP32 or ESP architectures operate at 3.3 volt, whereas Arduino UNO operates at 5 volt. Okay, so that means you need to give, in order to run the Arduino module, you need to give 5 volt input power supply. You can give it from a battery, or you can power up the Arduino module from your laptop also. Okay, you can also directly power up an Arduino module from your laptop even. Similarly, you can also power up an ESP32 with your laptop also. Okay, so the operating voltages vary from board to board. For ESP32, it's 3.3 volt, whereas for Arduino UNO module, it is around 5 volt. Okay, so there are two different kinds of signals that we can give it to that an Arduino UNO can accept or it can generate. So the first thing is digital signal. So digital signal is like a discrete. So discrete means it is having a, with respect to time, it can have either a value of either 0 or 1. Okay, 0 means low, 1 means high. So high refers to its operational voltage. Let's say if ESP32 is operating at 3.3 volt, then high refers to 3.3 volt. For Arduino UNO, high state refers to 5 volt. That's how you need to change the threshold values. I mean the value for high state. So as we change the module, or else as we change the microcontroller architecture, the reference voltage would change. Okay, is this point clear?
Yes, sir.
So basically, this is how a digital signal would look like. But whereas an analog signal, it's like a continuous waveform. So continuously, it will be like a could be anything, could be a sine or anything. It's like a randomly, it's of a different kinds of shape. Okay, that's an analog signal. We will also jump into there are few other concepts called ADC and DAC, analog to digital converters and digital to analog converters. There are two different things. We will discuss them in the upcoming session. So now, yeah, we have one PPT also. I'll share you. Yeah, I hope my screen is visible, right?
Yes, sir. Your
Yeah,
screen
Hemant.
is visible.
Fine. Thanks for the confirmation. So first you need to understand different parts of UNO. This seems to be very theoretical, but you are very beginning to Arduino, right? So you need to understand the different parts of a Arduino module. So basically, we have 80 mega 328p microcontroller. Okay, this is the, as you can see on the image, this is the 80 mega 328p microcontroller. This is the main microcontroller where different calculations, the arithmetic operations, everything would happen internally. So how this would happen? With the help of a transistor. So in the upcoming when you are going into higher standards, then you will come to know there are something called latches, flip flops. So any idea about latches and flip flops? Flip flop or latches?
Yes, sir. Flip flop is, I think, is made from the AND gate and NOR gate, something like this.
Oh, nice. Where have you learned this thing?
Sir, actually, I was interested in watching some YouTube videos, so I got it from there.
Okay, fine. So a flip flop can basically can store only one bit of memory. It can store either true or false. That's how a flip flop, it can hold a value if it's a positive or negative. I mean, sorry, not negative. If it's a high or low. Okay. So low means off state and high means on state. So all these flip flops, latches, there even in flip flops there are three different types. I just don't know whether you remember them or not in the from the lecture. There is something like D flip flop, JK flip flop, T flip flop. So do you remember them or you just know basic idea, right? Okay, it's fine. Knowing about flip-flop, that's very good, fantastic. You did really good job. So you can just also watch those sessions. There are multiple lectures available on flip-flops as well. JK flip-flop, D flip-flop, T flip-flop, how different things happen, the circuit diagram, schematics, everything is available in the internet. You can go through them. So similarly here, see every microcontroller can able to do the calculations because internally they have a separate unit where calculations can happen, and a separate unit where the program data can be stored, and there is separate unit where a separate memory is allocated for the runtime. So while the runtime also some memory needs to be stored. Okay, so there are memory architecture is divided in different sections. Okay, but everything is packed in a single IC, integrated circuit. We call it as a microcontroller. Here there are different microcontrollers. This is 80 mega 328p, which you find on the top of the mounted on the Arduino UNO. Okay, up to here everything
Yes,
is
sir.
clear, right? And here you have a reset button. This button we use it for reset functionality. So uh, like if there's anything went wrong, you can reset. You can just simply press the reset button, and uh, we call it as the pull down reset functionality technically. And this is the port where you can connect, you will be connecting one terminal USB port to your laptop COM port. Like you have some slots, right, where you can connect a pen drive or USB pin. So with the help of that, you will be uploading the code from the Arduino IDE into the this Arduino module that will be stored in the microcontroller only. There is separate memory unit where the program will get stored. Okay. So whatever the program that you are doing in embedded C, it's not directly stored in the way that you do program. That will be compressed in a binary format, and then it will be uploaded into this microcontroller, so that the microcontroller can understand and process, because all the electronic things can understand only if it's 0 or 1. Other than that, it cannot understand anything, right? So this is the power jack. Okay, just remember, we call this as the power jack. So through this power jack, you can supply the power with the help of some battery or something like that. Or else, see, if you are connecting this port, okay, to your laptop, there is no need to use this power jack, because already the power, it can derive the power directly from your laptop. Okay, and this Arduino can function independently. Or else, if your laptop is not there, let's say you uploaded some program and you unplugged it, you ejected this Arduino UNO from the COM port of your laptop, and then you gave it power supply with the help of battery. Still, whatever the program that you have already uploaded into the Arduino UNO, okay, when it is connected to that laptop, that program is entirely stored in the microcontroller, right? That will start getting executed. Okay, let's say if you want to programmatically blink an LED at every specified interval, you already made a program in Arduino IDE in embedded C, and you uploaded that program, you ejected, you disconnected Arduino UNO from your laptop, and you gave it a power supply with the help of a power jack with an external battery, or we call it as an external power supply. So still the program is already retained in the microcontroller, it is non-volatile. Okay, as soon as you remove eject it, the program won't get vanished. So if you have uploaded it properly, it will store in a non-volatile memory. That means it is not, even even if there's no power supply, the data is still retained. Okay, we call such kind of data as non-volatile memory. Basically, the memory can be classified into two different types: volatile and non-volatile. So whenever, if you remove the electricity, immediately the data, whatever the data that is there, it is lost. That is the volatile memory. Even if there's no power supply, still the data is retained. That we call it as the non-volatile memory. So later you give it an external power supply, still the LED blinks programmatically at whatever the time that you specified in the program. Because the program is there in the microcontroller, it is stored in the non-volatile memory. So you are powering up the Arduino module with a battery, it is getting power supply, and then the program gets executed. That's how thus the LED gets can blink at that in same whatever the time interval that you provide in the program. Okay, so is this clear about a volatile and non-volatile memory and the microcontroller?
Ye- Yes, sir.
Yeah, so that's what mentioned here. We have 80 mega 328p microcontroller. We have digital IO pins. So these IO means input output. Okay, basically these pins can act as either input and, both input and output. So you might have a question: how can a single pin act as an input and output, right? Isn't it? So
Yes, sir.
what exactly do you mean? Let's say if some pin is acting. See, we have total 14 pins on Arduino UNO. Okay, 14 GPIO pins. I'm digital. Okay, general purpose input and output. Someone is trying to join the meet. Varnit. Yeah, yeah. So there are GPIO pins, general purpose input and output. These GPIO pins can be classified into two different types. Okay. So the first thing is digital IO pins. In digital IO pins, there are total 14 in total, and there are 6 analog pins. Okay. So I told you, just like, see, can just name few peripheral devices of your PC, few peripheral devices.
Sir, keyboard, mouse,
Yeah,
and screen.
perfect. So similarly, for Arduino UNO also, we can connect to few other components as well. let's say you can connect to something like a temperature sensor, pressure sensor. So you can connect different kinds of sensors. Just like when if keyboard is connected to your laptop or else your CPU, it can access the data from the keyboard, right? That there will be a data transmission between keyboard and your system. So similarly here, if you connect there are multiple sensors. If you connect the sensor, there will be a communication between I mean bidirectional communication between Arduino module and the whatever the modules that you connect with it. Okay, note that I'm saying it's a bidirectional, not a unidirectional. Yono can communicate with the sensor, sensor can communicate with Yono. So if there's only unidirectional, then we can't build all the things, right? It's a bidirectional. So there's a bidirectional communication. And we call this as the master slave relationship. Just make a note of it. We call this as, technically we call this as the master slave relationship. Okay, master is this Arduino Uno, okay, or specifically this microcontroller. This is the master. And whatever the other devices, let's say your computer is the your laptop is the master, and keyboard and all other things you just assume like as if they are the slaves. Similarly, this Arduino is the master. Whatever the other external sensors that you connect to this Arduino module, they are considered as the slaves. Okay, so the relation when you connect to this a master and a slave, we call it a technical, we call it as the master slave relationship. Is that clear? Master slave relationship.
Yes, sir.
Yeah. So now coming to I told earlier that a pin can act either as an input or else as an output. Okay. So keep input aside. So let's say we are having different pins, right? I told you there are total 14 digital pins, IO pins. Let's say here it is already marked. This is the 0. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it is 13, but including 0, it's total 14 pins, 0 to 13. Okay. And if you just closely observe, okay, rather than I'm revealing that. So can you observe any change? I mean, between this pin number 9 and 8 in the labeling?
Yes,
Do
sir.
you,
There is something, a line, something like this
yeah,
on 9.
yeah. So basically a symbol is there, right? Before the number. So those pins we call it as the PWM pins. PWM. And what's the full form of PWM? PWM means progressive with modulation. Okay. PWM, just make a note of it. PWM means progressive with modulation. Is that clear?
Yes, sir. Noted.
Fine. So in this total 0 to 13, that means there are total 14 digital IO pins, the digital input and output pins. So out of them, a few pins are reserved for PWM, progressive with modulation. So in the upcoming sessions, when once you got the Arduino setup and everything, we will be working on them. I mean, we will be doing hands-on project, hands-on simulation. What exactly these PWM pins are, those kind of stuff, we will be working on it. So basically, as of now, we need to remember out of these 0 to 14 pins, few pins are can do the function of the progressive with modulation. They can modulate. They can do the modulation stuff. So therefore, they are called as progressive with modulation pin. What exactly this PWM refers to? These things we will be discussing in the upcoming sessions. So it is already clearly labeled here PWM. Whatever the pin which is prefixed with this symbol, we should call them as the PWM pins. It is already clearly labeled here inside the parentheses, right? So basically they are the progressive with modulation. And also one more thing, the 0 pin, we call it as the RX pin. Another name for 0 pin is RX pin. And another name for digital IO pin, GPIO number 1, that is TX. Okay. So it is already clearly labeled in the Arduino module itself. 0 means RX and 1 means TX. TX means a transmission, RX means a reception, receiving. So this is about digital IO pins. We will be in the upcoming session. We will be exploring in detail uh, about this. How to set. See, every pin can act as either. among these 14 digital IO pins, each pin can act as either input or output. So how you need to configure whether the pin should act as input or output, that will be programmatically decided. In the embedded C program, you will have to configure it, whether the specific pin should act as an input or it should act as an output. Okay.
Okay, sir.
So now I will tell you two examples. So for the two examples, you need to tell whether the pin should first, because before understanding how to set a pin as an input or else an output, first you need to understand at what scenarios, at what circumstances you need to set the pin as high. I mean, sorry, at what circumstances you need to set the pin as input, and at what scenario, at what case study you need to set it as low. So I will tell you a few examples. So you just try to answer them on yourself whether in that particular situation it should be configured as an input or else output. So let's say the case number one, you have an LED. Okay, the basic example, you have an LED. Now the pin should act as an output or else the pin should, you need to connect the LED to Arduino UNO. So Arduino UNO have total 14 pins, 0 to 13, labeled as 0 to 13, including pin number 0, total 14 pins. So out of these 14 pins, few pins are PWM pins, progressive with modulation pins. Keeping these all things aside, I told you pin can either act as an input or output. So now you have connected LED to the Arduino UNO, maybe some pin. Let's say pin number something like a 7. You connected one terminal to the pin number 7 and another terminal to the ground. Okay. See, every device, every component to work, it requires two things, right? VCC and ground. VCC means a positive supply. Just for sake of your understanding, you can understand VCC means a positive supply. Just like a battery have two terminals, positive and negative. Here we refer them. Hereafter we will be referring them as VCC and ground. Okay. So ground means which is at lower potential, and VCC, as you know. Fine. So now one terminal you connected to the ground and the another terminal you connected to the pin number 7. Now, should we need to configure the pin number 7 as input or else should it be configured as the output?
I think it should be act as an output.
Yeah. So any explanation, I mean, any explanation for your answer?
Sir, actually the bulb has to blink as an output, so I think that it should be like this.
Yes, perfect. Your analogy is perfectly correct. So the LED should blink, right? See, I already told you, whenever, see, with this GPIO pins, we can transmit the signals. So signals, it's not the term seems to be very sophisticated and complex, but actually the internal meaning is very simple. If you take this, if you just feel everything is complicated or complex, you feel it's complex. But if you start thinking all the things in a simpler way, everything is very simple. So similarly here, the thumb signal should be having a deeper meaning, but here we are actually transmitting the voltage pulse. So basically how we need to understand, if you just connect an LED directly to a battery, what happens? Directly the LED will glow. So instead of that, what you did is like you connect, just like as if you connect the negative terminal, like one terminal, which is, in LED we have one terminal as longer leg, right? It have two terminals. One will be having a longer leg and another will be having shorter leg. So the terminal which is having a longer leg, we usually connect it to positive. The leg which is shorter, we connect it to the negative. So similarly, you connected the shorter leg or else one terminal to the negative. Here, negative, like we call it as the ground pin. Okay, GND, ground. And you have the longer terminal which should be connected to positive. So here you connected it to pin number 7. So by default, pin number 7, it does not carry any voltage. Okay, by default it does not carry any voltage. It's like a floating pin. Now once you configure pin number 7 as output pin, okay, in the embedded program, then what the microcontroller actually do is like it will it will route this pin number 7 to the 5 volts. See, already you are supplying the power, you are already providing the 5-volt power supply from this power jack, right? So internally there would be an architecture. However, whatever you program in the embedded C, that whether the pin should be configured as the let's say whatever the pins which are configured as the output pins, they will be routed to a specialized bus, okay, power rail, which are connected to the 5-volt power supply. Is that fine? Are you able to follow?
Sir, could you please repeat? I can't understand it clearly.
Okay, fine. So if you connect an LED directly to a battery, what will happen? It will glow continuously. No sooner you powered it up with the help of a battery, it will start glowing. So here why it is glowing? Because you are having a voltage source, right? Battery is the voltage source which is driving it's like a driving force for electric current. Is isn't it? This thing is clear, right? If you connect an LED directly to
Yes,
a
sir.
battery, it will glow continuously. Similarly, here what actually happening is you just assume the Arduino UNO as something like in between the voltage source or else the power supply on one side and the LED on the another side. So what actually happen is instead of uh, it does not allow the voltage to be directly flown to the LED all the time. It will control it. Sometimes it will allow, sometimes it will stop. Okay. So when it should conduct the electricity or when it should prevent it, that thing can be configured through programmatically in the embedded C program. Is that fine?
Yes, sir. Now it is clear.
Yeah. Now I will tell you one thing. So if you directly connect a LED to a battery, let's say 5-volt power supply, then immediately the LED would start glowing, right? Now instead of connecting it to a battery, now you connected that to the Arduino UNO, and in the program you have set the pin. Okay, the pin, one pin should be connected to the ground. That's always common, just like as if you connect one terminal to the negative of a battery. See, similarly here we call it as the ground terminal. So you connected one to the ground terminal. Now another, we are left with another pin which should be connected to a positive power supply. So if you connect it to a battery, it will work. Now instead of that, you connected it to the pin number 7. Now you programmed in the Arduino UNO that the pin number 7 should be configured as the output. Okay, and then see output, configuring a pin as an output, it doesn't necessarily mean that the pin is in high state. So this point is very important to understand. Configuring any pin as output mode, it doesn't necessarily mean that it is in higher state. Do you understand this point?
Yes, sir. Noted.
Yeah. So can you just repeat the same point?
Yes, sir. I have written in my regional language.
Yeah, I know. I think you are from Haryana, right? If I'm not wrong.
Yes, sir.
Yeah. Okay, fine. So, uh, once you configure the pin as the output mode, so in output mode, for every pin will have two different states. One is higher state and low state. So when if you set the pin, first you need to set the specific pin that you are using. Either it should be input or output. For LED, it's output because you need to supply the voltage through that pin. Then only the circuit will get closed. For one terminal, it is getting a positive supply. Another terminal is obviously connected to the ground. The circuit of the LED will get closed and it will get powered up. So, so that's from this we can understand it must be configured as in the output state. In the output mode also, there are two different states, internal states. One is higher state and the another one is low state. So if you simply configure the pin as if you simply configure the pin in the output mode, the LED won't glow immediately because you have to fix the state, whether it should be higher or low. By default, it will remain in the low state only. Despite you configured the pin into output mode, still the pin remain in the lower state only by default. So lower state means it is having 0 volt. So once you configured it in the higher state, now what happens is like you are already powering up the Arduino module with a battery, right? 5-volt power supply. Now the voltage from that battery will reach the LED. Only when if the pin is configured in the output mode, and in the output mode it is set to higher state. Is that clear?
Yes, sir.
Yeah. So now if you want an LED to glow continuously, so what you need to do? In the Arduino UNO, you have connected an LED. If you want the LED to glow continuously, what you need to do? Very simple
Sir,
question. Yeah.
I have to put the output pin on the pin number 7, I guess.
Yeah, let's say for example we have taken 7. Yeah, okay, you have to set the output mode, and then
And then I can't actually explain it quite well,
so there are two different states, right? One is low state and another one is high state.
but
You need
it's
to
high
set it,
state. Yes, sir.
you need to set it to high state, correct?
Yeah.
Now you need to set it to high state for only certain time, or you need to continuously the pin should remain in the higher state. If you want the led to glow continuously, obviously the pin should remain in higher state only continuously. Is that correct?
I don't think so. It should, you know, uh, I can't say.
See, I told you whenever the pin,
Yes.
yeah, whenever the pin is in higher state, then only the LED will glow. If it is in low state, it won't glow. So I'm telling you now, if the LED needs to glow continuously, okay, then the pin obviously must need to be in the higher position continuously. Whenever it gets low, immediately the LED will also, its brightness will also decrease. Once this pin reaches completely low voltage, immediately the LED will stop glowing. That means if it is in high state, then only the LED will glow. If it is in low state, the LED will stop immediately. This is the fundamental principle. Fine. So now I
Okay,
told you
sir.
that,
So
yeah. Now I told you that LED can be programmatically, you can programmatically, you can blink it. So I told you if it is in high state, let's say you want to blink an LED at every 2 seconds. Okay, so how will you be doing that? At every 2 seconds you need to change the state of the that particular pin. By changing the state of the pin, like from high and low, let's say at 0 second it is at high position, or else it is at low position. After 2 seconds you need to turn that pin into high position. So since it is in high position, immediately the LED will glow. Again after two seconds you need to set the pin into low mode, I mean low state. Then the LED will stop blinking, I mean stop glowing. And again after 2 seconds, again you need to set it to high. That's how we need to continuously toggle the state of the pin. So if you toggle the state of the pin from high and low, so what will happen? The LED will also accordingly, if it's whenever it is in high state, it will glow. Whenever it is in low state, it will stop glowing. That's how you will blink an LED at a specified interval. Is that clear?
yes, sir. It is clear.
Yeah. So now you are continuously toggling the state, right, from high state and lower state. So for that, if you just draw the graph, this is what you get. That's what I told in the earlier session. Isn't this what I told, what I explained you right now? This is high state, this is low state. Again high, again low, high, low. Okay. Is this clear now? Now you are able to understand everything, right?
Yeah, sir. It is relatable now.
Yeah, that's fine. So that's how you can programmatically operate an LED. Not an LED, you can operate multiple things. We will be seeing in the upcoming sessions also. Yeah. And here one more thing is like this ATmega 328P, which is a microcontroller. It is having 8-bit processor inside. Okay, 8-bit processor. And for everything, for each and every microcontroller architecture, it will have something called a crystal oscillator. I'll show you how crystal oscillators would look like. There are different variants of just like a resistor, capacitor. Crystal oscillator is a component, okay, electrical component, electronic component. So don't go in much detail about crystal oscillator right now. Yeah. So there are multiple crystal oscillators. There are multiple types. So as of now, you need to understand only one thing, that there is an electronic component uh, called crystal oscillator, and each and every crystal oscillator will have a frequency. For Arduino, I mean for Arduino UNO, there it will have a crystal oscillator of certain frequency. For ESP32, there will be a crystal oscillator of some other frequency. Is that fine? So different microcontroller architectures can have crystal oscillators of different frequencies. So here for Arduino UNO, the frequency uh, of the crystal oscillator is 16 megahertz. So this frequency we also call it as the clock speed. Okay.
Yes, yes, sir.
So now you have a same set of instructions. Let's say a similar program you uploaded in Arduino UNO and you uploaded in ESP32. So in which module do you think the instructions will get executed fastly in Arduino UNO or else in ESP32?
ESP32.
Because it is having a crystal oscillator of higher frequency than the Arduino UNO. Okay, so you need to decide how fast an instruction can execute based depending upon the frequency of the crystal oscillator or else the clock speed. Okay, you need to decide. uh, you can only able to determine how fast the instructions will execute in a particular microcontroller architecture only based upon the frequency of the crystal oscillator, which we technically call it as the clock speed. For Arduino UNO, it's a 16 megahertz. For ESP modules, they are higher. So I already told you that inside every microcontroller, there are different sections for memory in memory unit, right? So here we are having three different sections of memory unit in 80 mega 328p microcontroller. So the first section is the programmable memory, okay, which we also call it as the flash memory. That's where your entire program, whatever the instructions that you are writing in embedded C, that will be stored in the flash memory, which we also call it as the program memory. Okay, and the second one is SRAM. In the SRAM, we only it is having very limited storage, only just 2 KB, 2 kilobyte. And one more question. Here it is also clearly indicated that flash memory is having the maximum size 32 KB. Let's say you are trying to make a huge project, okay, not simple project, very huge big project. So as the project complexity increases, obviously the number of lines that you need to do in the embedded C program would also definitely increase, right? So for bigger projects, usually we don't recommend Arduino modules. Inamal, for PCB design lab, we are postponing it. It will be conducted at something like 3:45 p.m. Mihir, you can post a message in the group that lab session will be conducted at 3:45 p.m.
Yeah, got it.
Yeah. So right now we are having some Arduino class going on. You can join at 3:45 p.m. Inamal. Yeah. So yeah, let me go back to the same thing. Yeah. So you're having a huge project. So for huge projects, usually we don't use the Arduino module. So can you just tell few such reasons why we don't use Arduino module for huge projects?
Said this for huge projects, the data would not be stored in the program of flash memory because we need of higher
Yeah.
higher
So
KBs.
there are multiple limitations. The first thing, primarily, we have a memory limitation. Arduino UNO can store only up to 32 KB. If your program is exceeding the size of the maximum allowed flash memory, then obviously you cannot upload that program. It will throw an error. Whenever you are trying to upload the program, it will clearly show you that your instruction or your program size exceeds the flash memory of the Arduino UNO. So we will be also seeing that. We will be also doing some simulations. If you upload a huge code, how it will respond. So we will be doing those simulations also in the upcoming sessions. So the first thing, we are having memory limitations and clock frequency. I already told you different microcontroller architectures have different clock frequencies. Clock frequencies is also one of the factor. Arduino UNO is having a little bit lower clock frequency. 16 megahertz, it's fine. For a simpler project, it's fine. Sometimes we may require higher frequencies, like we need to execute the instructions so rapidly, right? So in those situations, it may not be suitable. The clock speed also is one of the important thing that we need to consider. And the another thing is the processing speed. It's an 8-bit processor. We are having some other thing like 16-bit processor, 32-bit processors also there. So basically, it is recommended for a hobbyist. If you're working on a small project, it's fine. It's a very good starting point to know about the higher advanced modules. So it's basically the starting footprint through which later on you will be exploring yourself the different things. Once you're done with Arduino module, you can explore ESPs. Then you can explore something like Raspberry modules. So that's how you can keep on learning, engage yourself. So we are having multiple limitations, memory limitation, capabilities, and the number of cores. ESPs are having 32 is having dual core, so it can run multiple tasks. It can schedule multiple tasks. It can perform different tasks at a time. We call it as the task scheduling. So these features are not there in Arduino. Let's say you want Bluetooth capability. So by default, Arduino module do not contain Bluetooth capability, but still Bluetooth capability, like you can still use you can incorporate Bluetooth functionality within an Arduino product using the Arduino UNO itself. How do you think it is possible? Any idea?
Sir, I think no idea, sir.
Yeah. See, I told you in ESP32, 82 Bluetooth functionality is not there by default, but in ESP32 we are having Bluetooth functionality inbuilt within the IC integrated circuit itself. The Bluetooth functionality is also there. So here in this Arduino UNO module, Bluetooth functionality is not there within the microcontroller, right? In this 80 mega 328p microcontroller, there is no Bluetooth functionality at all. But I told you that this Arduino UNO can communicate with its peripheral devices. I mean, just like few sensors. So it is having some digital IO pins, and it is having we say, it is also having analog pins, right? Just like you connected an LED to a Arduino module, similarly you can get an external Bluetooth module. Bluetooth modules are also there. You can connect that Bluetooth module. See, for ESP32, no external Bluetooth module is required because already Bluetooth functionality is there within the microcontroller itself. But for when it compared when you come to Arduino UNO in this 80 mega 328p microcontroller, by default no Bluetooth functionality is there. But it doesn't necessarily mean that you cannot use an external Bluetooth Bluetooth module, right? Is that clear?
Yes, sir. Now.
Yeah. Similarly, in ESP82 is also not having the Bluetooth capabilities, but still you can get an external Bluetooth module and you connect it with ESP32. So now with the ESP32, you can control that Bluetooth module also. I told you between them there exists a bidirectional communication pathway. Is that fine? I will show you Bluetooth module also. Bluetooth module for Arduino UNO. See HC05. You can connect it to Arduino module. If you connect it to just like ESP is having an antenna, I told you it is having an onboard antenna, right? So are you able to recognize this kind of antenna you might have seen in a ESP32 module, which which you have seen yesterday? You are able to remember that, right?
Yes, sir.
Onboard antenna. Yeah. Similarly,
Yeah.
see, ESP32 is having an antenna, but ESP82 is also having an antenna, but Arduino UNO is not having any kind of antennas on that. So it cannot make any kind of wireless communications by default. So unless you connect an external module with it, you cannot make a wireless communication, right? So this is the HC05 module. It is responsible for Bluetooth functionality. If you connect this module to the Arduino UNO, then Arduino UNO and this HC05 can communicate with each other. You can operate this HC05 with Arduino UNO through program, where this program will be situated inside the flash memory of 80 mega 328p. So you'll be doing a program that how the Bluetooth functionality, like how this Bluetooth module should work. Those kind of instructions you are doing program in Arduino IDE, and you are uploading that into the Arduino UNO. It will be stored in the flash memory of 80 mega 328p microcontroller. And now from the Arduino UNO, like you are connecting this HC05 Bluetooth module with Arduino UNO. So now you are giving a power supply, maybe through the power jack with the help of a battery. Now Arduino UNO gets powered up. As soon as it gets powered up, there are few instructions which are stored in the flash memory. It will start getting executed. So these instructions are directed towards the HC05 module, and whatever that you program, that will be executed. Like that, however you want HC05 to operate, accordingly it will operate. Is that fine?
Yes, sir.
Yeah. So I hope up to here everything is clear, right?
Yes, sir. But I think I need to revise it as there's some bit details that
Yeah,
you have
sure.
given.
Yeah, sure. Definitely. We are, the video is also being recorded. We are having a YouTube live stream also. We will share you the link later. You can refer to that. Okay. Yeah. So now we
Oh,
told
okay,
that there
sir.
are three sections in memory. First one is the flash memory. So we have time up to 3:45 p.m. Like we can discuss for uh, something like a 20 more minutes. Yeah. So we have flash memory and we have SRAM and we have EEPROM. Okay. EEPRYM, EPROM. So EPROM where in even EPROM also some data will be stored. It is also a non-volatile memory. Even when the YONO is turned off, still in EPROM the data gets stored, just like the flash memory. Flash memory is where your program gets stored. Even if the module is not in powered up state, still the flash memory is also non-volatile. EPROM is also non-volatile. But EPROM is having lower memory, just like only 1 KB, very small. So that means you will be storing in EPROM only if you think it's very essential and very important, something like a configurations, settings. So those stuff you will be storing in the EPROM. Okay. And SRAM is having total 2 KB of size. This 2 KB will be used during the runtime also. Sometimes we need to store some data during the runtime. So that runtime memory will be stored in SRAM. So in Arduino UNO, there are three different versions: R1, R2, and R3. So the latest version of the Arduino UNO is Arduino UNO R3. R means revision 3, the latest version. Okay, the Arduino board, as you can see on the top. So this is the Arduino board, right? So in this board, there are three different variants. The first one is R1. That's a very first version, basic design, and then they have enhanced it. They improvise the USB stability and improvise the reset functionality. And right now you can see the reset functionality, right? So they improvise the reset system and they came up with a new module called UNO R2. And finally, we are having Arduino UNO R3 with extra pins for communication. Yeah, there are different kinds of communication protocols that we'll be discussing in the next session. There are a few I told you that uh, Arduino UNO is a master. All the things which are connected to UNO, they are the slaves, right? So I'm communicating with you with the help of English language, right? So similarly, these can communicate with the help of different protocols. The master and the slave can communicate with each other with the help of different protocols, like I2C protocol, SPI protocol. There are multiple protocols. So these things you will be learning in the upcoming sessions. As of now, you can understand that there are few protocols like I2C and SPI protocol through which a master can communicate with the slave. So here in the earlier example, let's say the Arduino UNO is the master and the HC05, the Bluetooth module is the slave. Assume like that. So there are different communication protocols. Fine. Yeah. So I
Yes,
hope,
sir.
yeah, up to here everything is clear, right? If you have any questions in the next few more minutes, I'm taking questions from you. You have any questions with you?
Sir, currently no questions as I need to revise the whole concepts clearly. I might have doubts. I will discuss in the next class, please.
Okay, fine. Sure, definitely. So do you think this session is informative? Any feedback from your end?
Yes, sir, your teachers class are really great. As for me, as I'm new, you're teaching really great.
Okay, fine. Thank you for joining today's session of a 21-day Arduino challenge with Suchana. This is Hemant, your dedicated mentor from Suchana, signing off. Bye bye.